Hello, this is a tutorial for your connected Electron configuration lab that you'll find in your student book. So you want to go to your connected site. You want to click on To Do. And you're going to view assignments. And it's probably going to be due later or due soon, whichever time you log into it. And it's called Virtual Electron Configuration Lab. My instructions are to complete the lab. There is an extension that is optional. I don't need to see that, but it is a good thing to do. And I want you to upload your completed lab here in ConnectEd and in our class lesson, just in case I can't find it. So there is, when you're done, this is the student view. You can push done and upload your sheet, and I'll show you where to find that. So what you want to do is just click on the virtual investigation. You want to click conceptual activity, and this is where you can print out, this is the worksheet that you want to save to your computer and then upload here and ConnectEd if you can, and in our lesson. So here are all the instructions that you need, so it's good to print this out. You can just print it here, and it gives you all the instructions as well. So the objectives are to use what's called the off-ball principle to determine electron configuration notations of neutral elements by completing their off-ball diagrams, and then compare electron configurations to determine exceptions, and then you can go through and see everything that you want to do in Exploration 1. So the inquiry extension down here is optional. Okay, so you're going to do electron configurations for potassium, hydrogen, and all the way down the list here. So the electron configuration notations here. The electron configuration using noble gas configuration goes in the second column. That's what we're going to be checking for. So just in case you don't remember what all that means, you can find it in Chapter 5, Section 3. And this is all about off-ball. It gives you examples of what that means. It's these diagrams. And so in chemistry, it's the electrons that do all the reactions, right? So we got to find out where they are in their ground state and how we would place them if they were according to the Bohr model of different levels of where they could be found. And so this is the diagram for that. And all through Chapter 5, Section 3, you can learn about the Pauli's exclusion principle, Hund's rule, and some more about electron configuration and some noble gas configuration here. So if you don't remember how to do that, go back to those parts of the book and notes and lessons to figure that out. So the first one that was on that list was potassium. So what you do is you just type in K, this element symbol. Okay, and if it doesn't work, you may have to restart it. That's all that restart button is. And so you want to, if you can't see it, you can click on the periodic table to see it bigger, to see how many electrons you're dealing with. So in its ground state, it has atomic number of 19. That means it has 19 protons and 19 electrons because it's neutral. So you're going to deal with 19 electrons here. So all you do is count. 1, 2. I'm clicking every time. 3, 4. These are easy because it does the Hund's rule as far as up and down electrons. So that's 4, 5, 6, 7, 8, 9, 10. Now what I did was I didn't put them all, I didn't put 2, 2, and 2 because that's Pauli's exclusion principle. They have to go in separate orbitals before they pair up. Okay, so we're up to 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, I need one more. So it is a 4s at the end there, and that's why potassium's so reactive, because it has one electron and it needs one electron to be full. So I can submit it to see if I'm right. That's right, and that's what I'm going to put in my worksheet. Okay, the conceptual activity, I'm going to put that electron configuration, and it is the big long 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, so you're going to write all that out. Okay, 1s2, 2s2, so on. Okay, and then over here it's looking for the noble gas configuration. What that means is what element, noble gas wise, is before potassium. So let me just get this out of the way here. Well, the element that is noble gas before potassium is argon, and it has 18 electrons. So its noble gas configuration for potassium will be argon, and then the last element, 4s. So in this activity, you can put argon, and you can use the brackets there, argon 4s1. That's the noble gas configuration. It's a shorthand notation for everything you wrote over here. So this worksheet will save for you. You can see I closed it and then I opened it back up and it saved. And you can save it again, and you can save it to your desktop, and then when you're done you can go back and upload it to your you can upload here. You can give it a name, drop files there, or select to upload. I didn't save it to my desktop, but you can do that there. Okay, and then also save it to the lesson. Let me know if you have any questions. Thank you.